Okay, chapter 8 is about linear transformation. Okay, linear transformation is about function in the form of vectors, where independent and dependent variables are vectors. Okay, we have learned in calculus about function, where function is in the form of variables, but now function is in the form of vectors. Independent variable is v, vector v, and independent variable is vector u, and dependent variable is vector v. Okay, for definition, f is a function where it is assigned from input v, vector v, onto output vector w. It's a function from vector space v. So now the input is vector space v. Into the output is vector space w. Then function f is called a linear transformation if these two criteria are met. So we need to fulfill these two criteria first, then only we say that f or function f is a linear transformation. Okay, criteria 1 is f of vector u plus vector v is equal function f of u plus function f of v for all u and v in vector space v. Criteria number 2, f is f a function of ku, where k is a scalar, u is a vector, is equal k f of u for all u in vector v and all scalar k. Okay, so we must prove that the left equation or left term is equal the right term or expression on the left. Left must equal right expression. Then only we say that f is a linear transformation. Okay, example. Determine whether T of V to R, where V is an inner product space and T of U equal norm U, is not a linear transformation. Okay, it's not a linear transformation. Okay, given T, function T is always given. Okay, T of U plus V equal to norm of U plus V. S is this one. T of u is norm u. So T of u plus v is norm of u plus v. Okay, from here we know that norm of u plus v is less or equal norm u plus norm v. This one is stated earlier in our notes. Okay, so norm of u, so this one is less or equal norm of u plus norm of v from properties of norm. So norm of u from here is T of u, and norm of v from here is T of v. So therefore, so this is T of u plus v, and this is T of u, and this is T of v. So therefore, T of u plus v less or equal T of u plus T of v. So since this is less or equal, not equal, so from property, there must be a criteria where the left must equal the right. So since this is less or equal, so it is not equal, so we have the unequal sign. Okay, the unequal sign. So the criteria number 1 is not met. Therefore, we say T is not a linear transformation. So therefore, T is non-linear. Okay, other term for linear transformation is non-linear. Okay, another example. Use the definition of a linear transformation to show that the function t assigned from space 3 to space 2 given by formula t. Remember, t transformation or function is always given. The expression is always given. So we need to follow that expression. Okay, t of x1, x2, x3, which is in space 3, is assigned to formula this. In space 2, then we only have two components. This formula first component, this formula second component. Okay. Right, so T, okay, let U and V be component in R3. Okay, let U and V be component in R3. So T of U is using this expression or formula. Okay, so T for vector U, where component U1, U2, U3 is assigned to 2U1 minus U2 plus U3 as this one. And second component is assigned to U2 minus 4U3. Okay, for T, V1, V2, V3, it is assigned to 2V1 minus V2 plus V3, and second component is assigned to V2 minus 4V3. Okay, for T of U plus V, okay, for T, U plus V, meaning that we have T component U1 plus V1, component 2 U2 plus V2, and component 3 U3 plus V3. So apply this to this formula. Apply to this formula, we have first component is this one. Okay, by applying like this one, U2 minus U3, U1 minus U2 plus V. So this is like U1, this is like U2, and this is like U3. So since U plus V, we have U1 V1, U2 plus V2, U3 plus V3. And the second component is given by this. Okay. Okay, so by solving the expression in the formula, so we have, so you need to simplify the expression. So we have something like this, the first component, and the second component is this expression. Okay, again, simplify it. At the end, we have this term, as you can simplify until you have got this one as the first component, and this is the second component. Okay, so this one is like T, U1, U2 and U3 as from the definition. And plus, so we can split this one into TU and TV. Okay, from here you get this one. And this one can be simplified into from the expression as T, V1, V2 and V3. So therefore, we have proved that T of U plus V is equal TU plus TV. So the first criteria is met. Okay, next for the second criteria, let find T of CU. So we need to show whether we can get C of T of U. Okay, now from the expression or the formula given, T is CU1, CU2 and CU3 is placed into the formula or the expression from the definition of T. So we have this one. Okay, so now since C is a scalar, we can factorize, we can take it out. Okay, so since we can factorize this or simplify this, C outside here in front, and in the bracket is 2U1 minus U2 minus U3. And second component B, U2 minus 4U3. And this is the expression of T. So it becomes CT of U1, U2, U3 from the formula given. So therefore, it is CT of U. So the second criteria is met. So since criteria 1, criteria 2 is met, therefore, we say that T is a linear transformation. Okay, another example. Show whether T assigned vector in R2, let's say x1, x2, is assigned to formula x1 plus 2x2 in R2 also. Okay, this is R2, this one also in vector space R2 using this formula x1 plus 2x2 in component I and component j 3x1 minus 3x2. Okay, check whether T is a linear transformation or not a linear transformation. Okay, so for solution, okay, now let U be element in R2, U1, U2. So T of U using this formula is T of U1, U2 is assigned to from here U1 plus 2U2. U1 plus 2U2 and second component is assigned to 3U1 minus U2 from here. X1 is U1, X2 is U2. Okay, now let V be vector in space 2 given by V1, V2. So T of V is T of V1, V2. Assign using the formula here. So assign to V1 to V2, 3V1 minus V2 is second component. Okay, so therefore T of U plus V is T of U1 plus V1 and U2 plus V2. Okay, by applying the formula here like this, by applying this formula, so we have, so since first component is U1 V1 and second component is U2 V2, so we have it is assigned to U1 plus V1 plus 2 U2 plus V2. Second component it is assigned to 3 U1 plus V1 minus U2 plus V2. And let's simplify this. So once we simplify these expressions, put in one place vector U1, U2 and V1 and V2. So we can simplify this expression and obtain U1 plus 2U2 plus V1 plus 2V2. Okay, and second component, we simplify and can get 3U1 minus U2 plus 3V1 minus V2. And try to form into two parts. Okay, for U1 and for U1, U2 and V1 and V2. Okay, so we form into two parts. So this one can be from the earlier expression here. Okay, we can get back to the left side. So this is the expression of T of U and this is the expression of T of V. So we can show that T of U plus V is equal T of U plus T of V. Okay, so this is the first criteria. So the first criteria is met. Okay, for second criteria, T of Cu is equal T of Cu1, Cu2 and apply the expression or the formula given. So we have got Cu1 plus 2 Cu2 and second component is 3 Cu1 minus Cu2. Okay, so now simplify this. We try to factorize C. Okay, try to factorize C. So we have C of this one and second component C of this equation. And take out C, put it in front, and then we have the expression in the bracket here, something like this. So this is the formula for T of U. So therefore, we can get C of T of U. C T of U. So therefore, T C U is equal C T of U. Second criteria is met. So therefore, T is a linear transformation.